This is the demo of my project, Medical Misinformation Detection chatbot, which is deployed using Kubernetes and it's deployed on GCP. So what it does is we enter a prompt such as novel coronavirus is man-made. So it would return a label true, false, or misleading. As the prompt is false, so it would return as false. So how it is deployed is I have 3 services currently running. Which are frontend, gateway, and Mongo. The gateway service uses the Mongo service to store and retrieve the chat logs, and the front-end service is the front-end. So I wanted to discuss that I have implemented some changes after the individual interview I had with the unit coordinator, and I implemented a horizontal autoscaler for the front-end service. So you could see qctl get HPA. What it does that when the CPU reaches 75% of the request I made, such as in the deployment I made a request of 150 M of CPU, and if 75% of that pod is exceeding that point, it's gonna create another pod, and the maximum pods that it would create, it would be 5, so there's maximum availability. Another thing I implemented is that I am using a replica set for the Mongo service, which is also a stateful set, and what it does, it actually helps me handle fault tolerance. Or so suppose if my pods goes down and I want my data to be protected, I need some sort of replicated or replica set for my database. So such as, let me get the pods running. As you could see, there are currently 2 pods running for the database, and if I delete one of the pod, suppose one of data center goes down and my data is still protected. See, I deleted my pod and you could see the chat history is still there, and this was protected using a secondary data set, and I could show you that. As you see, if I go inside a Mongo pod and check the status of my pods, and which I recently deleted, Mongo 0 is now the secondary, and it did an automatic election who will be the next primary, and it elected Mongo 1 as the next primary, and my data is retained and protected. So another thing I'm making sure is that I have set limits and requests for each deployment, so one pod doesn't misuse the resources, and this also protects the pod from misusing the resources, as you could see. Another thing I added was pod level security using service accounts. Suppose I created 2 service accounts, such as one for the front end and one for the gateway. So it allows me pod level security. So my front end doesn't has access to Kubernetes API, which is intended. This is the pod level security I want to implement. My front end or gateway pod should not have access to Kubernetes API, like all of it. It's the basic RBAC I implemented. Although I did mention the routing between front end and backend services was done using the ingress controller, which is Nginx ingress controller. Yeah, that's all from me. Happy coding. I hope you like my project, and I am applying for high distinction. Thank you. That's all from me. Bye bye.